All right, our first formula is the simple interest formula, which this is I equals PRT. You've probably seen this before. P is your principal or the original amount. T is the time in years. R is the interest rate, which is a percentage written as a decimal. So typically you're going to find the interest or find the ending balance. If you find the interest, you just plug everything into your formula and multiply. Now, of course, this section we're going to do a little bit trickier. Real quick, let's define some words. So if it's annually, that would be, once per year. If it's semi-annually, it's twice per year. If it's quarterly, it's 4 times. Monthly, it's going to be 12 times. And if it's daily, it's 365 times per year, right? Okay, our first example is that a credit union pays interest of 2% compounded quarterly on a certain savings plan. If $1,000 is deposited in this account and the interest is left to accumulate, how much is in the account after 1 year? So some keywords here. We have the 2% interest rate, compounded quarterly, and then $1,000 is accumulated or is deposited. This word accumulate is a big one too. So let's write down kind of some things we know for our variables. We know our formula is I equals PRT. Our principal is that $1,000 that we put in. Our interest rate is 2%, but we write that as a decimal, so it's going to be 0.02. Now our time, here's the tricky one. T is in years. So if it compacts quarterly, that means a quarter of the way through the year it stops and collects interest. So that means our time has to be 1/4. Now it's going to do that 4 times a year, right? So we're actually going to plug everything into our formula 4 different times. All right, so let's start. So our formula I equals PRT. Our principal is $1,000. Our interest rate is 0.02. And our time is 1/4. If you type all that in your calculator, it's going to give you $5. So after, 1/4 of the year, you got $5. Add that to the original principal for the next time. So our next round, we have I equals, our new principal is now 1,005. Our interest rate stays the same. Our time is still going to be 1/4. Multiply that through, we get 5.03. So this is halfway through the year at this point now. So let's plug it all in again. So add the 5.03 to the 1,005. That gives us a new principal of 1,010.03 times 0.02 times 1/4. This gives you $5.05. This is 3/4 of the year, so we have to do it one more time. So let's see, add that to your original, not the original, but the 1,010 principal. Let's see, we have 1,015.08 times 0.02 times 1/4. That gives us 5.08. So last step, add that final interest amount to that last principal that you had. So that gives us 1,020.16. That is your final answer. That tells you how much is left in the account after 1 year. So you can see you've earned $20.16 in interest over the year. Okay, fortunately for us, we have a formula that's compound interest formula, which allows us to plug everything in like we did last time, but rather than having to do it all 4 times, we just do it once. Because this is the compound. It's when interest, we stop after 1/4 of the year, we take that interest that we earned and we add it to the principal. That's what it means to compound. So this formula, we have A equals P times the quantity 1 plus R over N raised to the NT. So A is your ending balance or your ending amount. P is your principal. R is your interest rate, which is again is a decimal. T is your time in years, and N is the number of times it compounds. So let's say we did the problem that we just did for example 1. So our principal is $1,000. And then it's 1 plus R, so that was your interest rate was 0.02. Now, the number of times it compounds. It compounds 4 times a year, right? Because it's quarterly. So 4. And then it was 4 there, and it was after 1 year. So 4 times 1. Now, this, honestly, type this into your graphing calculator. Just type it all in. And then you're going to get, see, the ending amount is actually slightly different, only by like one penny. It's different, and that's just due to rounding. So the previous slide we got $1,020.16. Now we have $1,020.15. So just a little rounding, but that's fine. But this was a lot easier than plugging it in 4 different times in the other equation. All right. This next example, I kind of want to show you one from MathLab. So I just took a screenshot of, this is problem number 1 in MathLab. And so it looks, yours should look similar, probably different numbers. So you're finding the amount, the results from the given investment. So we have $5,000. We're investing at a 7% compounded daily after a period of 4 years. So start, the formula we're using, A equals P times 1 plus R over N to the N T. And just start plugging everything in. So A equals, our principal is 500, and then 1 plus your interest rate divided by the number of times it compounds. So if it's daily, that's 365 days a year. Raised to the NT, so raised to the 365 times 4, because it's 4 years. And when you type this in your calculator, you want to round it to the nearest the nearest cent, which is 2 decimal places, the nearest hundredth, 2 decimal places. So you type it in, let's see, we get 661.547, keeps going. So we know that that is $661.55, final answer. And then I will also post another video that will show kind of how I type this all into the calculator. Because I type it all in at once and press enter, and that saves, it saves me a lot of time. But I will show you, I'll post a video that'll be, 6.7 calculator. So we'll show you how to do this on the calculator too. Sometimes you might have where the interest compounds continuously. So it's rather than daily, it's just kind of like every minute, every second, it's always just continuously compounding. Then we use a different formula. We use A equals P E to the RT. So A is your ending amount, P is your principal, R is your interest rate, again as a decimal, percent as a decimal, and then T is your time in years. And then E, that is, the exponent function that we kind of talked about in previous sections. So it's on your calculator as well, and I'll show you another calculator video of how I type this in. But yeah, this is one, it's on your calculator. All right, example 3 is an example of continuous compounding. So we want to find the amount A that results from investing $1,000 at an annual rate of 10% compounded continuously after 1 year. So if it's continuous compounding, we know we're going to use the formula A equals P E the RT. So start plugging stuff in. Our principal is $1,000, and then it's E raised to the, R is 10%, so 0.10 times 1, because it's just 1 year, right? So when you type this in to your calculator, you end up getting $1,105.17. All right, sometimes we may not have the principal, but we have like a present value is what we call it. So we would have a value where, all right, we don't have our principal, but what kind of a principal would we need to put into our account in order to have $500 2 years later? So to determine the principal needed to get a certain value, we use a different formula, and that equals P equals A times 1 plus R over N raised to the negative NT. So you use this when you don't have the principal and you're trying to find the principal. Here's an example from my math lab. So this is example 3, and it is where we're trying to find the principal needed now to get a given amount. So we're finding the present value. So in our case, we want to get $200 after 2 years at 5% compounded monthly. So we're using the present value formula. P equals A times 1 plus R over N to the negative NT. So let's plug in what we know. We don't know our principal. We know our value is going to be $200 times 1 plus our interest rate is 5%, so 0.05. 0.05 divided by, so it's monthly, so that's 12, to the negative 12, because it's monthly, times 2. All right, when you type all this in your calculator, you should get 181.01. So this would be the principal that would be needed in order to have $200 in the account in 2 years. Okay, sometimes you're going to figure out an interest rate. So like, for instance, this example, we're going to try to find what is the annual rate of interest compounded annually that is needed in order to double an investment in 5 years. So let's say you had $500, you want to double that in 5 years. You will be looking at what is the kind of the best interest rate for you. So our formula, remember we're using this one, A equals P times 1 plus R over N raised to the NT through compound interest. Now, we don't know our principal in this case. However, we don't need to. We know that by the end, we want double the principal. So our A is actually going to be 2P equals P times 1 plus our interest rate R. That's what we're trying to figure out. So R over, so N, if it's compounded annually, it compounds once. So R over 1 times, so N, 1 times 5, right? Compounded annually, so that's 1 times 5. All right, now let's move this P to the other side. So in order to do that, what we're allowed to do, divide both sides by P. So now we have that 2, because these just cancel here, 2, equals 1 plus, let's see, R divided by 1 is just R. 1 times 5 is just 5. So now, this looks a little weird, right? In order to cancel out that raised to the 5th power, we're going to take the 5th root of both sides. So we're going to do, the 5th root of 2 and the 5th root of 5. So bring it up here. So we now have that the 5th root of 2 equals 1 plus R. Move that 1 to the other side, so minus 1, minus 1. So the 5th root of 2 minus 1 equals R. So you type that in your calculator, the 5th root of 2, which I'll show you how to do one of those as well. I'll do another video of the calculator video. You should get that your interest rate is about 0.15 or 15%, depending on how they want you to round it to. All right, sometimes you're going to need to find the time required. So like example 7, we're going to try to figure out how long will it take for an investment to double in value if it earns 5% compounded continuously. So compounding continuously tells us we use this formula, A equals P e to the RT. And so now we're plugging in what we know. We want the principal to double. So our ending amount is going to be 2P. And now our R, our interest rate, is 0.05, and our T, we don't know. Now, we're going to start this just like we did the last problem. We're going to divide both sides by P. That gets rid of that P there, right? So now we have that 2 equals E to the 0.05 t. Now, we want to rewrite this. Well, basically, we're going to take the natural log of both sides, because this will help us kind of get rid of that e and bring that 0.05 t out of the exponent. So when we do that, we have the natural log of 2 equals the natural log of e to the 0.05 t. Natural log of 2 stays the same. These cancel, and we have 0.05 times t. Now divide both sides by 0.05. This cancels. Plug it in your calculator. You should get that t is about 13.86 years. All right, so we are done with this section. This last slide is just a summary of all the formulas and kind of all the terms, what each variable means. I would pause and take notes on this, because you can use your formulas when you're doing, your homework.